So I'm going to name this 1-2D because I think I lost track on my numbering lettering system of 1-2B and C. So this is D, no matter what, even if you can't be like, I can't find C. Yeah, I think I messed it up. So I'm hoping we've kind of got the concept of IQR and box and whisker plots and spread and center, because this section is, and we're still in 1-2, it's a doozy. This section now shifts to understanding choosing a number summary. So how do I know what numbers I should use to describe a distribution? So we are going to address choosing a number summary. If we have a symmetric distribution where our mean and our median are dang near the same and we don't have any extreme skewness, it makes sense that we would want to utilize X bar and S because they're not going to be pulled by outliers. If we have a skewed distribution, so remember tail right or tail left, that one doesn't look terribly skewed. There we go. In that case, we would want to use the 5-number summary with min, Q1, median, Q3, maximum. And the reason is because these three in particular are resistant and they won't be pulled by those extreme potential outliers. So when we have skewed data, that box and whisker plot would make the most sense to be our graphical representation, because if you're going to do the 5-number summary, you might as well do the box and whisker plot. When we have symmetric data, we're probably going to choose a histogram, but we can do a histogram or a box and whisker plot anytime we want. But if I'm trying to partner them up, the mean and the standard deviation fits really well with the histogram, the box and the whisker plot, obviously the 5-number summary, because that's what builds it. So think back to the fact that we're playing with quantitative variables, things where we can do calculations with our data. It's so important that we go back to that acronym of Picasso's. So you have to plot it, and really, I don't know if we're going to do a lot of stem and leaf plots because your calculator doesn't do them. And why? My dog's deciding to take a nap, so she just went, sorry if that bothered you, but she's adorable. So when we talk about that plot it, stem and leaf plots aren't going to be that great by hand because no one wants to do anything by hand. If you have them, you can read them, but you aren't going to create it. So if you have to create it, a histogram or a box and whisker plot, it's handy because your calculator simply does it for you. So that plot it, make your choice. Center. Well, that is, I'm trying to find my highlighters. The center, that would either be X bar or your median. Spread, S or your Q's. Shape, well, you're going to see it. Outliers, we have a way to calculate it. Remember that an outlier right now is 1.5 IQRs above Q1, above Q3 or below Q1. My brain is going too fast for my mouth and my hands. Sometimes we want to choose things that get our point across the most. And I'm not trying to say that you are constantly going to be manipulated by data, but you're constantly going to be manipulated by data. And the sooner you recognize that and understand, the sooner you might actually be able to make your own distinct decisions while understanding the influences around you. So for example, if the median salary is $40,000, but the mean salary is $60,000 because we have an outlier or 5 sitting out there, what would I use to represent the truth, because they're both true, to influence someone else's opinion or decision? Well, if I want to say, hey, this group of people is paid a larger amount of money, I would represent the mean. If I want to say they're underpaid and they need to get a raise, I would represent the median. Both are true. So when someone is using data to try to help you come to your conclusion, you need to ask, well, why are you using that? What other pieces of the puzzle are out there that could maybe have you look in the opposite direction also at truth? And that's a difficult thing to do as an adult, as a teenager, and in our current world. And the sooner we start understanding that, the better off we're going to be. Because there is probably data out there to provide evidence for any particular stance. But how good is that data? Is there more data, more significant data, that might lead you down a different direction? It's an interesting world in which we live, and there are many times where people will try to persuade me based on a data piece or some statistic or fact, and I just smile and I go straight for the throat, because I don't want to do that. I want to think for myself. I want to find the information, and then I want to make the best decision that I can. And people will try to manipulate you. That's just human nature. And the more educated you are, the better decisions you can make for you. And I think that's one of the reasons I love statistics. And I have people in my life like, no, it's this, and I'm just sitting there smiling, and someone else will come along, oh, she's going to destroy you. And it's fabulous, because it's all true statistics, and I love it. All right, so let's take a look at page 89, number 43. I know, I haven't eaten. I told you that in the last couple of videos. I have not moved from my chair in hours. I don't know that I wanted... There it is. Ooh, no, I want you guys to do number 43, so we'll probably talk about this. There was another one. Here we go. Number 45. I can't remember if I have that assigned to you guys or not. So on problem number 45, I'm on page 97. I will zoom in. Raising teachers' pay. Hey, I think that's the exact same example that I used. So, a school system employs teachers with salaries between $30,000 and $60,000. The teachers union and the school board are negotiating the form of next year's potential increase. Suppose that each teacher is given a flat I don't want to do that one yet. I lied. Okay. Just know that you guys are going to be able to choose between mean and median to influence someone. I need to take a break. So the next thing that we're going to do is we're going to talk about comparing distributions. I'm sorry. All focus. We're human, and I'm not recording this again. I'm 8 minutes in. Deal with it. So we need to have our data, and we need to organize and examine. We need to know all of those basic little baby questions. Who collected the data? What variables are we looking at? Why was the question asked? Why was the data collected? We need to know when, because I could tell you there is data that indicates that children that cry more tend to have a higher IQ. And I can tell you that because it's in the book. But that experiment, I believe, was done in the 60s or the 70s. And at that time in that experiment, what they did was they took a rubber band and they snapped an infant's foot with it, which is highly not ethical right now, and listened to them cry and recorded the peaks of the sound of their crying, the amplitude, and then attempted to associate that with IQ later in life. Why would we do that? When was that done, and is that maybe appropriate? When it was done, is there more data out there that may contradict it because it's 50 years old? Who wanted to know that? Because sometimes the who really determines the results, because we get pressure to slant a viewpoint a certain way. And remember that what we do is we look at this with graphs and number summaries. And then our focus is to interpret and make predictions. That's the word predictions. I know you can read it because you heard me say it. Here's the one I wanted to do, and it was just a little bit lower on the page. Number 47. I'm still on page 97. The table below gives the distribution of grades earned by students taking AP Calc and AP Stats. And this is from 2005. Let's see. Were you guys born? Maybe? I'm not really sure. You would have been tiny. So make a graphical display to compare. Write a few sentences comparing the two distributions of the exam grades. Do you know which exam is easier? And so that's something to really think about. Like if you look at, and you may not be familiar with AP exam scores, 5 is the goal. 1 means you took it, 5 means you nailed it. Well, right here, more people got 5s. Ooh, but here more people got 4s and 3s. Fewer people got 1s. So it's not as simple as who all got the 5s. We're looking overall at who did better. And so in this problem, which I'm actually going to assign to you, you need to make a graphical display. However you choose to do that is completely up to you. But then really be thinking about who did better. Look at peaks, look at symmetry, look at skewness. It's going to be really interesting. And the way you present your data could allow someone to believe, oh, students do better in AP Calc. The way you present your data could lead people to believe, oh, students do better in statistics. And that's just something to be aware of. Really be looking at what's being thrown at you in our world. And if you think, oh, well, that's just 2020. No, that's our world, and it has been and will be. So you need to kind of get through some of this stuff. We have one more topic. Ooh, here's another example. Page 102, number 58. So which measure of center, the mean or the median, should you use in the following situations? Middletown is considering imposing an income tax on citizens. The city government wants to know the average income of citizens so it can estimate the total tax base. Now careful, I know you're seeing that word average, you're like, mean. Average, when people are writing, doesn't necessarily mean average. It often means typical. So wouldn't you think that a city government wants to assess as much tax as possible so that it has money to function and do whatever it is, or it may or may not do? We ain't going there. Well, in that case, would you want the median where it's not being pulled by extremes, or would you potentially want the mean if you have a fewer higher paid citizens? So when you put it that way, I think we would go with the mean. And if you're like, yeah, because it says that, I tried to find the answer. We would go with the mean because we want the most dollar out of that situation, and that would include the higher end outliers. The median would be in the center. It's not going to get you as much money. On B, in a study of the standard of living of typical families in Middletown, a sociologist estimates the average, so think typical family income in that city. In that case, we would probably choose the median because we want to know more typical. The extremes aren't going to help or hurt. We want to hit that typical. Another example can be real estate. So if you're trying to convince people, hey, come move to our community because real estate, what are the house prices? Well, in that case, you would want to choose the lower of the mean or the median, because if you can show that there's a lower house price, more people can afford it and it's more livable. And so then you'd want to look at which one's going to be most effective, the mean or the median. Now, if you have a lot of lower priced properties, the mean might actually be lower than the median, because if you've got a lot of properties that aren't developed, just lots of land, then your prices might be less. It's all in how you want to convince someone to make a decision based on the data that you've given them. Okay, the last topic that we need to address in this section, and it's kind of like a little left curve, and that's why I always leave it for last, is that it deals with changing units of measure. So how do we change the units of measure? Well, what exactly does that mean? Well, let's say that I come up with a distribution, and I'm going to hopefully have you guys have a chance to see this. Let's say that we are at 10, 12, 13, 13, 15, 18, and 20. Okay? So I'm going to put that data. I am going to come into list 4. I'm going to hit clear and delete, or clear. Oops. I can type. Okay. Here we go. I'm going to go into calculate. We're going to calculate list 4, and I'm going to scoop my calculator so that I can write. Our mean is 14.4-ish. Our standard deviation is 3.5-ish. And I'm going to come over here for our 5-number summary. The min, that's 10. Q1 is 12. Q2, which is the median, I don't know why I called it Q2 right there, 13. Q3 is 18. And the max is 20. Okay, so that's our distribution. But let's say that this is hourly pay, and we want to give everybody a flat raise. So I'm going to use my highlighter. We're going to do a flat raise of, everybody gets $5 more an hour. Focus. You might have heard of fed. My husband got some food. My dog's following. So we're going to go in, and I'm going to add 5 to all of these. I'm going to go up to list 4. This is actually really kind of cool. I'm going to tell my calculator like a rule. I'm going to program it a little bit. So notice how L4 is highlighted. I'm not sitting on the 10. I'm sitting on L4. And I need to zoom out just a bit because the focusing is having some issues, and you need to see my keystrokes. Focus. There. Okay, so I'm going to tell my calculator L4, so second number 4, and see how that pops up the L4 down there on the bottom reader of my screen. Plus 5. I'm telling the calculator add 5 to everything in L4. Hit enter. Beautiful. Okay, let's see what happens. Let's go to stat. Let's go to calculate one variable statistics on L4. I know you can't see it. It's having some issues. Well, if we add 5, the new X bar is 19.4. The new standard deviation is 3.5. The new minimum is 15. The new Q1, 17, median 18, max 23. I know those are small, but let's compare. X bar went up by 5. S didn't change. All of these went up by 5. Ooh, what about the IQR? The IQR in the original of 18 minus 12, that's 6. The IQR on this one, 23 minus 17, is also 6. Okay, so what changed? Maybe faster to say what didn't change. Standard deviation did not change. IQR did not change. Everything else did. So if we were to take a distribution and name it X, if I were to add the same value to X, X bar, your median, Q1, Q3, min, and max would all increase by that value of A. Your standard deviation and IQR, guys, your spread won't change. And you might ask, well, would that work if I subtracted, if I gave everybody a pay cut? Yep, it would be the same. And so why is that? Well, let me get my purple. If these are our purple peoples, and this is our distribution on a number line, Those purple peoples are literally shifting 5 steps up. Is their spread changing? No. They're just moving 5 steps to the right. So their middle will move up, and their mins and their maxes will move up, but their spread will not change. There's no stretch. It's just pick everybody up and go. It'd just be like saying, okay, do you remember when you were little and you had to do a program for the holidays or something, and everybody lines up and they go from petite to tall, and I'm like, now everybody stand on the riser. Everybody's height just went up 2 feet. Your spread didn't change. You still have your petite and your tall giant. But everybody else's stuff went up 5, so your average is now higher. Hope that makes sense. What about if we were to do a multiplier? So if we were to take this same distribution, and I'm going to go with pink, and I'm going to have everybody double their original salary. You'll be able to see that in a second. So I'm going to go into stat. I'm going to go back up to L4. I'm going to hope that my computer focuses. That's not focused. That's still not focused. Hang tight. Focus. This is what we got. Focus. And if you're like, why don't you do autofocus and focus lock? It doesn't work. I've tried. It truly does not work. So I'm going to go up to the tip top of L4, not the 15, but the L4, arrow up so it's highlighted. And I'm going to tell my calculator second number 4 for L4, and I'm going to subtract off everybody's $5 an hour pay raise. So I'm just bringing us back to our original data. But now I'm going to go up to the tip top of L4, and I'm going to give everybody a double, like times 2. So the person that was making $10 is now going to make 20, etc., etc. So I'm waiting for this to focus. I'm going to go second L4 times 2. Look, it all doubled. So let's see what happens to all of our values. I'm going to go to stat, go to calc, one variable statistics on L4, and I'm going to scoot. Our x bar when we double everything is now 28.8-ish. Our standard deviation is 7-ish. And then I'm going to scroll down, and I'm not going to write the labels because they're all the same. The minimum is 20, the Q1 24, median 26, Q3 36. Am I off? I might have messed up. That should have maybe been a Q3, and then I think I skipped the maximum, but you get the idea. And then let's talk about our IQR. So our IQR is 36 minus 24, and that becomes 12. Now let's compare it. So I'm going to do a little zoom. Let's compare my pink double to the original. X bars, 14 to 28. I think that doubled. 3.5 to 7, doubled. Min, Q1, median. I think I messed up writing something down in here, but you get the idea. It all doubles. The IQR doubles. So if we are going to take a number times our distribution, all values change based on the multiplier. Now, if I were a really mean boss and I was like, nope, everybody's going to get their pay cut in half, well, then all of the values would be cut in half. So it adjusts by said factor. Kind of interesting, right? And you might be wondering, okay, why does the spread change on this when it didn't change when we just added a constant? Well, if this is my distribution and I'm going to double it, this lower guy has to go 2 times further, and this one has to go 2 times further. It's a stretch. Do you remember ever going to the fair or Springfest, the carnival, back before COVID when we used to have such amazing things in our lives? And those mirrors where they'd make you look like really tall and stretched out, or really like a teapot, short and stout? That's kind of what's happening, and it's stretching those factors. I'm curious, does the range change? That was not intended to rhyme, but it did. The range on the original one was 10. The range on the other one when we added 5 remained 10. So that spread is being very consistent when we add. We had a minimum of 20 and a maximum of 36. I think I just had an oops in there. 36 minus 20 is 16. Oh no, I'm sorry. Our maximum would be 40. 40 minus 20 is 20. The original range was 10. Yeah, everything gets changed by said factor. So that is how we change units of measure. Now I want to take a look at number 45 on page 97. I got myself back together. So number 45 asks, how much will the mean salary increase if everyone gets a flat raise? Won't everybody get an extra $1,000 in the mean and the median? Yep. Will the flat $1,000 raise increase the spread? Nope. Will a flat $1,000 raise increase the spread by standard deviation? Nope. Now what if we gave everybody a 5% raise? Now be careful. If we're going to give a 5% raise, everybody keeps their original rate, their original salary. So it's actually a 1.05 multiplication factor. The 1 keeps your original salary and the 0.05 gives you that 5% boost. So I think you guys are going to be assigned number 46. I'm not telling you. Don't cheat. All right. Holy cow. We just finished section 2. Remember, I'm going to name this 1-2d because I messed up my other stuff. And then I think I'm going to take a break. Bye, guys.